Okay, so in this video, we're going to do vertex form and factored form, and I'm going to breeze through them. It's not going to be as long of a video, but because I'm actually going to use Desmos as a tool for this, um, because I think it's important for us to do that, to use the tools that we have. Um, so Joe is a professional deep water diver. His altitude in meters relative to sea level, X seconds after diving is modeled by this. So altitude and seconds, right? So altitude, what's important about altitude, it's not like seconds where it cannot be negative. Altitude can be negative, okay? So if we look at the graph of this function, which I already have planned over here, right? If we look at the graph of this function, let's go closer to 0, right? It starts at 0, at 0, 0, right? It goes down. It is concave up. How can I know just from this function right here that it is concave up? Because your A value is positive. So it is concave up, meaning it has a minimum, not a maximum, right? Which we can see right here. So now look. So I have 0, 0. It starts at 0, 0, meaning he starts at sea level. He goes down underneath water because he's a deep sea diver, right? He goes underneath the water and then comes back to the surface. Okay, so let's look at the questions that this asks us. And you know what? Let me do this. So I don't have to draw it myself. Because let's be honest, I'm not an artist by trade. So here's our graph. So now look, we have the question, how many seconds after diving will Joe reach his lowest altitude? So lowest altitude tells us what? Our minimum. So our vertex, right? But it says how many seconds. So are we dealing with time? So let's label this graph here. This is time versus altitude, right? So is this time or altitude? Well, this is time. So we're dealing with our X value. So actually, this is technically X, right? X, which is time. And so because we're dealing with time, we are going to find the X value of the vertex. So our vertex is already given, but we already could have found our vertex easily from our function, right? Because it's in vertex form, 50 and negative 100. So we already know our vertex is 50, negative 100. So therefore, it is, time is there. So it's 50, what is it in seconds? Yep, 50 seconds. It takes him 50 seconds to reach his minimum point. And then it says, what is the lowest altitude? So again, we're still dealing with the vertex, but it's not asking us how long it took us to get there. It's asking us what it actually is. So still the vertex, whoop, but it's not going to be the X value. It's asking us for what the actual lowest altitude is, and that's negative 100. So negative 100 feet. How long will it take for Joe to come back to the surface? So it's asking, so he started at the surface here. He went down, 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 and then came back up to the surface. So how long will it take? So again, how long is asking for time, right? So again, time, which is X, and it's asking when it comes back to the surface. So altitude, A of X, is equal to 0. So we're looking for the intercepts. And so what are the intercepts here? It is 0. This is where he started, but this is when he came back to the surface. So it's at 100. 100 seconds, which is what, a minute and 40 seconds? So it's not that long. All right, 100 seconds. Now, just for review purposes, just to really quickly, if I wanted to actually find what that was, right? So 1 over 25 x minus 50. squared minus 100. I can just use the square root property. Add 100. Multiply by 25, so I'd get 2,500 equals x minus 50 squared. Take the square root. I would have gotten 50 equals plus or minus 50, x minus 50, and then I would have added 50 to positive 50 and negative 50. And I would have gotten 0 and 100. So that's just how you would do it algebraically. Factored form. So a rocket is launched from a platform. Its height in meters, x seconds after launch, is modeled by this function. So I already put it in Desmos. Here it is. Boom. Now let's use a different color. Purple. So here's my function. It's pretty steep, right? And so it goes all the way up and then all the way back down. So the question here is, what is the height of the rocket at the time of launch? So at the time of launch, meaning t equals 0, what is the height? Meaning we are dealing with height. So again, we have to define our variables. We have h of t, which is height, and this is our y-axis. And then we have t, which is our time, which is our x-axis. So what is the height of the rocket at the time of launch? So t equals what? Nope, just kidding. H equals what when t equals 0? So I plug in t equals 0, or x technically. Oh shoot, it's an x, not t. X. So x equals 0. X is t here. So I have to plug in x equals 0. It's pretty simple. You just plug it in. So h of 0 equals -4 times 0 plus 2 plus 0 minus 18, which is -4 times 2 times -18. So I get 8 times 18, which is 144. So 144 feet in meters. 144 meters. Now, let's look at the graph. It should 144 meters, my y-intercept. There it is. Boom. Next, how many seconds after launch will the rocket hit the ground? So when will it hit the ground? Meaning h now is equal to 0, and we are looking for how many seconds, so we're asking what is time? T equals what when h equals 0? So now I have to set h of t equal to 0, or h of x. I keep putting t. H of x, right? So 0 equals -4 times x plus 2 and x minus 18. Now, these are the easiest things to find, right? Because you just have to use your t-chart. So x equals -2 and x equals 18. So the question is, am I going to use, which one gets canceled, right? The negative, because I'm not going to have, if I throw a ball up here, I'm not going to have negative time. We don't like negative time, right? We like moving forward with our lives. So 18 seconds. Okay, right? Seconds? Yes. 18 seconds. And then here, how many seconds after being launched? So how many seconds? We're still dealing with t, right? So t equals question mark. Oh my God, x, but it's time. So x, t, time, whatever. After being launched, will it reach its what? Maximum. So that means we're dealing with what point? The vertex. And then here it says, what is the maximum height? So again, maximum, but it's asking for height. So it says, it's asking what is h, but we're still dealing with the vertex. So here, we're just going to go to the graph. We're going to look and say, okay, what is the vertex? Vertex is 8, 400. So we gotta translate that. So if my vertex is 8,400, then I need to know how many seconds after being launched will the rocket reach its maximum. Well, we're dealing with seconds, which is time, which is x. So we're dealing with 8. So 8 seconds. And then what is the maximum height, which is h, which is y. So it's 400 meters. And then we're done.